Have a look at the July 2020 question 1. With starboard side 2 in salt water with a 5-degree port list. So starboard side 2 but a 5-degree port list. Even keel draft 6.28 kg given. And there's a 15-ton piece of cargo to be loaded using our own derrick. It's 13.3 metres from the centre line. And the derrick head is 21.5 metres. And we're given its stowage position, and we're asked to calculate the maximum list, size and direction of any list. So do the first two bits. So we have to figure out when the maximum list would occur. So generally speaking with these problems, it would usually be when we initially pick the weight up, but of course with starboard side and with a port list. So we're going to have starboard moments, but we've already got port moments on board. So in this problem, the maximum list will actually occur when we've picked the weight up, slewed it over, and when it's directly on our centre line. Because we're holding the weight high up, therefore our GM is being affected, and it would increase the list in excess of 5 degrees, even though it's on our centre line. Our angle of list will be more than 5 degrees because of course it's affected our GM. So we'll look at the calculation, go in the tables at the draft, get the KM and the displacement to work out our initial listing moments, 283 to port. There's our weight there of the vessel or displacement. There's the 15 tons being held, creating the moments. The KM of course changes slightly, so the angle of list will be the listing moments 283 divided by GM times displacement, and it gives us a 5.7 degree list to port. So the list was 5, it's now 5.7, and the listing moments assuming the derrick has swung over the centre line of the vessel. So I've just put that in to remind you that's when it occurs. Now the actual list once we've loaded, well, the 15 tons now changes from 21.5 to 3.5. And of course the list moments aren't going to change either. We've got the 283. So the list now goes to 5 degrees to port. Now what the question then asks us to do, let's have a quick look at the question. So we worked out the maximum list and the size and direction of any list once the weight is stowed. Of course we stowed the weight on the centre line, which is why our listing moments didn't change. Now how much ballast do we load in the number 2 double bottom side tank to bring the vessel upright? Well, we know that moments is a weight times a distance. So we know what listing moments we have to get rid of, the 283. We go in the tables for number 2 double bottom side tank and see the TCG is 6.48. Divide the weight at the moments by the TCG, and that gives us the weight that has to be involved, 43.7 tons. So the ballast to load in that tank is 43.7. Now we have to work out the kg of the vessel on completion. Well, all we need to do there is remember, of course, that we've put the 15 tons on board. Now we've got the 43.7, and what you mustn't miss out here, of course, is the fact that we put ballast, therefore we've got free surface moments. So we go in the tables and we find for fresh water the free surface moments are 680, convert those to salt water because it's the ballast, and that gives us a kg of 8.21. And the last part, does it comply? Well, that's the simplified maximum kg table. We're just simply going, and the kg allowable at our displacement is 8.28. Therefore, the vessel comfortably complies. So that's how we would answer the first question. A couple of tricks there. First one, of course, when would the angle of list be maximum? And the second one, not forgetting your free surface moments. Now we'll have a quick look at question 3. And this is a inclining experiment, We're given all the usual information. So what you have to remember, of course, with this is that the boiler water is part of the vessel. So the boiler water and the free surface moments of the boiler water have to be crossed out and not be involved in the problem. And we've got this lifeboat temporarily located, and it'll be stowed the following week at the correct kg. So we're given all the information there, and let's see how we set it out. So it's the usual 50 by 11.3 by 9.93. When you look at your formula, divided by the displacement times 0.74, which is the distance moved, and we get a GM of 1.39. So the kg will be the 10.88, which is the km minus the 1.39, 9.49. So initially we have to work out our GM, then the kg with the weights on board. I would always suggest that you list and name all the different weights that are involved. So if you make some sort of clerical error, it probably won't be classed as principal. Obviously these are all my own workings as well. I don't get any answers, it's just my own interpretation. So I've listed everything there, and with the lifeboat what I've done a minus and a plus. That way I can't get it wrong. Minus and a plus, so I've taken it from this position of kg and placed it here. So by my own workings I get a lightship kg of 4912 and a kg of 9.89.